Welcome back to the fourth lesson of chemistry, and the topic of today's lesson will be redox reactions. So what are redox reactions? Put simply, redox reaction is just a transfer of electrons from one chemical to another. And more specifically, we want to talk about the transformation from chemical energy to electrical energy. Now, we've been focused quite a lot on energy lately, and this is when we're going to apply what we understand about it. But before that, we need to understand a little bit about oxidation and reduction. So oxidation is defined as the loss of electrons, and meanwhile, reduction is defined as the gain of electrons. Now, there is a very important golden rule that I want all students to understand when we're talking about oxidation and reduction. Whenever we talk about, the charge of electrodes, for example, an anode and a cathode, a lot of students straight away jump the gun and just simply say an anode is the negative electrode and the cathode is the positive electrode. But that's not always the case, and it causes a lot of confusion when students reach electrolysis, which is a later on topic. So instead, I prefer teaching students the golden rule, which applies for both galvanic cells and electrolysis that we'll be studying later on. And this is, oxidation will always occur at the anode, and reduction will always occur at the cathode. So regardless of whatever context we're talking about, whether it be electrolysis or galvanic cells, both these rules apply. You will always have oxidation at the anode and reduction at the cathode. And one quick way of remembering this is oxidation, anode, O and A both start with vowels, and vowels goes with vowels. Reduction, cathode, R and C, both consonants, and consonants goes with consonants. Now, a lot of students then get confused at this point here when we're talking about oxidant and reductant. Oxidant initiates oxidation, but itself gets reduced. So in other words, you will generally see an oxidant in a reduction half equation. Why? Because oxidation starts off oxidation, but itself gets reduced. And meanwhile, reductants, it will initiate reduction within the reaction we're talking about, but itself will get oxidized. So in other words, a reductant generally exists in a oxidation reaction. Now, a simple way of remembering everything we've talked about so far is simply by an oil rig cat. And the best way to understand this is an oil refers to anode goes with or in oil for oxidation. Rig cat, cat for cathode, R in rig is for reduction. So oxidation always occurs at the anode and reduction will always occur at the cathode. Now oil, that simply stands for oxidation is loss, which means oxidation is a loss of electrons, and for rig, reduction is gain. So reduction is the gain of electrons. So very simply, just as long as you remember an oil rig cat, you will have the basic foundations of redox reactions. So your homework for this week will be to investigate the concept of oxidation numbers. Because if I gave you a reaction, how would you basically tell me if this was a redox reaction to begin with, and how would you be able to tell me which one's an oxidant and which one's a reductant? And that is why I also want you to look at what's special about oxidation numbers for oxidants and reductants, because you'll find that they don't often obey the rules that we may think they will